Hello, this brief video demo brought to you by Calnex will highlight the benefits of the Paragon-X's unique new master-slave functionality. The application is focused on testing the timely recovery of real slave devices and the performance of TC and BC network elements. Its principal function is therefore to provide emulated 1588 message flows into and out of these devices, onto which PDV profiles can be superimposed, and to perform correlated analysis of message captures and embedded 1588 timestamps. Now, existing Paragon-X recovered clock measurements run in parallel with master-slave emulation to evaluate slaves and boundary clocks with the recovered clock outputs. Packet domain measurements are used to evaluate transparent clock correction field performance, plus a new timestamp transfer accuracy measurement, TIMTAM, is introduced to measure the performance of boundary clocks that do not have recovered clock outputs. The application also allows exercising of 1588 header and message fields to provide protocol functional testing of real devices, and in particular provides emulation of two independent masters simultaneously to test best master clock algorithms in slaves. So let's move on to the actual user interface. So we'll demonstrate how intuitive and easy it is to set up and how easy it is to make measurements with the Paragon-X master-slave capability. So master-slave capability is associated with the 1588 version 2 operating mode. Selecting it enables the master-slave emulation workflow button and forces transmit-receive interface mode. It's additional to the impairments generation and PDV timing measurement functions in the Paragon-X, and these measurement functions remain available while master-slave emulation is in use. So the emulation functions are intended for testing protocol functionality, e.g. best master clock algorithms, leap second time of day processing, etc., and for providing active sessions on which to superimpose PDV profiles and hence test slave clock recovery. So next we'll select master-slave emulation and graphically display the user interface within the Paragon-X, which shows how the Paragon-X is intended to be connected to the device under test. This is the instrument's main setup screen. All the necessary settings and fields are brought out to a single simple graphical interface to allow detailed pre-conformance testing beyond what's viable with network equipment today. The Paragon-X can emulate one master and one slave, or two masters. These two configurations are mutually exclusive. Now we'll cover master-slave configuration, but first of all we'll demonstrate the two masters configuration. First of all we'll go to slide and show the best master clock algorithm. So two master testing allows for evaluation of best master clock algorithm, BMCA, functions within slaves, where different master parameters are offered to slave and its response observed. The Paragon-X presents each master on a different port. Now if you need operation to single device under test port, then use a switch to combine both these ports. Now capture can only be assigned to one of the masters at a time, and capture messages in both directions from the assigned master. Configure impairments also allows impairments in both directions. So to perform best master clock algorithm testing, go back to the user interface here. So this is done by selecting two masters, which we've done here under device configuration. Then by selecting configure master, the user can easily set under announce message the appropriate clock class settings. So for instance we have clock class here of 110, which you do not use. We'll set this to PRC 84. Then we'll go to master 2 and set clock class here to, for instance, SEC, which is 104. Now going back to master 1, you see we have 84 primary PRC. So switch that now to DNU 110, and what would happen now is that a connected slave would switch to the alternative master, master 2. So what we'll do now is we'll go to the GUI prototype here tool, which actually shows it as being connected to, as if it was connected to real equipment. So what you would see here is that the connected slaves would switch from one master to the other master, and you'd see that these connected slaves here switch to master 2. So that is the way you verify best master clock algorithms using the Paragon-X. So now let's go back to the real GUI on our instrument here. So let's look at the master general settings in more detail. Under general settings, the user can select mode selection, auto or forced. Auto invokes full 1588 signaling, whereas forced, so full 88 signaling, where the emulated master responds to unicast messages from the slave with unicast grant, etc., whereas forced causes immediate transmit by the emulated master of the announce and sync messages at the selected rate. Now the encapsulation choice is IP version 4 or directly into Ethernet. If you select Enable Multicast Announce Messages, now the default's unticked, so all the announce messages are unicast, but if this box is ticked, multicast announce messages get sent in addition to, not in place of, unicast announce messages. Now both unicast and multicast message rates are set in subsequent master setup pages described below. In the case of selecting multicast announce messages, the number of allowed slaves reduces from 8 to 7. So having looked at master general settings, now let's have a look at the master allowed slaves settings. So firstly, under connection, in the case of Ethernet encapsulation, which we covered earlier under general settings just a second ago, the only choice would be direct or switch. Otherwise, the user can select a routed connection, as chosen here. Now in this case, there is no ARP process on the master transmit side, so it's necessary to specify the router MAC address, and this would be selected here. Note that there is an ARP process on the emulated master receive side, so any ARP request from a connected real slave will get a response and allow the slave to proceed with the connection with the master. So under configuration, if auto detect slaves is selected, slave details are populated according to the incoming slave request messages. In this case, the first 8 slaves to identify themselves will fill up the available slots, and no more can be accepted. Now the maximum message rates for announce, sync, and delay request messages, delay response messages, can be set below according to the populated global, and then apply globally to all the populated slaves. Now if manually is specified, then up to 8 slaves, 7 in the case of multicast, can be specified by IP MAC addresses, as shown here. And each specified slave can have different message rate settings. Under manually specified slaves, here we can enable each slave and see the list of slaves being added to right. So for instance, if I go to slave 2, click enable, you see it being added here. Go to slave 3, click enable, you see it being added here. So this is the way we set up the allowed slaves with the master. Let's go back to auto. So having looked at master general settings and the master allowed settings in more detail, let's have a look at the master common header settings in more detail. So the values here map to the 34-byte PTP message header. Note that in 1588 PTP, some header message values are compounds of others. In other words, the common header source port identity field, it's a combination of clock identity here and the port number here. So the Paragon-X GUI breaks these compound values down to their individual components to make manipulation and setting much easier. The fields below with the tick boxes at the bottom of the screen, these all combine to make up the flags field within the 1588 common header structure. So lastly, on the master settings, let's look at the announced message settings in more detail. We touched on this earlier. So as noted, the separate fields in user interface, clock class, clock accuracy, and the offset scaled log variance, these combine to populate the Grand Master Clock Quality field, which is at byte offset 60, within the skip, within the announce message body. Now just briefly I'll mention something I forgot to mention under general settings. If you set the seed time and date here, they can be set close to midnight, and if the Leap 59 or Leap 61 flag components in the common header are also set, it's possible to observe slave behavior in inserting or deleting a second from its time of day output as it rolls through midnight. So we've been told that the ease of seeing and changing the master parameters versus a network equipment device is extremely important, as the only way folks can get real master equipment to do this, or anything like this, is generally to go through some sort of backdoor settings, and even then the engineers can take ages to do it via the command line interface. So let's go to the prototype tool here a second, and look under master slave. So for master slave configuration, the device under test can be one of 4 devices. It can be a slave clock, a boundary clock, or a transparent clock, or a master clock. And this is indicated in the GUI here under test configuration. So for instance, we've got slave test here showing a slave clock down here, and the way that the master and the Paragon-X is connected to it. Then you can also set the master test, so the device under test here is a master, and here we have the Paragon-X with slave emulation, and show how it's connected to the device under test, the master. Then let's choose boundary clock, and here we can see how the Paragon-X in master slave emulation mode is connected to a boundary clock, which is the device under test, and showing all of the connections and measurements that can be made. Lastly, let's have a look at transparent clock, and here again we see the Paragon-X in master emulation and slave emulation modes being connected to transparent clock, and you'd have a traffic generator here to load up the transparent clock. So now we'll concentrate on how to perform a slave test. As we are doing a slave test, we'd normally choose master and slave. I'll go back to the user interface here. So back into test setup. So normally we would do this in master and slave mode, but for demonstration purposes here, we will configure this into master mode, as the prototype tool cannot make real measurements, and the actual instrument GUI supports 2 master mode in the initial release. So the slave test procedure is to use master slave emulation to establish the 1588 session, and then the user would use the Paragon-X to import and replay the PDV profiles. So we're in slave test mode here. What we'd then do is go into add impairments and delay, go into user defined, and we would import a G8261 test case profile. Now we would need to import a profile for each direction. So the G8261 profile files are available on the Calnex website, and they're labeled to identify their direction and packet rate. Now the replayed profile for each direction would then be displayed with a red vertical bar above the graph showing the progress of the replay of the delayed profile. So having done that, the user would then go to measure the slave's recovered clock quality against these standards. So the way to do this is to measure the slave clock output frequency, in this case E1 wonder, and we do that by hitting Start Capture from the menu bar as we've done here. Then we select Graph, Graph Context, and we want to look at E1 T1. This is the tie data, put it into graph mode, and here you see the graph data, the E1 wonder graph tie being displayed. Go into graph mode, show a second graph, turn that on, and now we'd want to look at the 1 PPS. So the second graph here is showing the 1 PPS accuracy being displayed. So if we go back to the E1 T1 graph, we may want to now do wonder analysis, in other words MTI-TDEV analysis. So from the graph, drop down here, we choose wonder analysis E1 T1, and that would pull up the wonder analysis tool. So it's loading the tie data, and here we see the tie data. To look at MTI-TDEV, click on the MTI-TDEV tab. Note we also have clock mapping and clock frequency, fractional frequency offset. Hit calculate. These will now be calculated too, and then you can see the clock mapping. So now we have clock FFO, clock MAFE, MTI TDEV, the TI data, all under the Wonder Analysis tool. And of course you can use the Wonder Analysis tool to measure MTI TDEV against the clock masks with an easy pass-fail indication. So having done this, we would now perform a transparent clock test. So doing this, we go to Prototype User Interface. So into 2 masters mode. Choose master and slave. Transparent clock. And you then configure the master as previously. And once you've done that, you would configure the slave. So we've already shown how to configure the master, so now we're going to configure slave. Now configuring a slave complexity is inherently far simpler than it is for the master clock. The couple tick box basically aligns the addressing and encapsulation types with the settings for the emulated master, which makes it very easy to do. So having done that, we'll next show you how to quickly set up the message details within the slave settings. The requested message rates are from 1 per second to 128 per second for the announce, the delay response and the sync messages, as shown here. Note, if auto renew is selected, then the slave is guaranteed to send a signaling message renewing the duration and the message rates before the current one expires. So the procedure for transparent clocks is to load up the transparent clock with traffic from a traffic generator, and then performing these tests, measure the correction field accuracy, which is a high precision latency measurement. So next we'd perform a boundary clock measurement. So let's go to boundary clock. It's shown here. So choose master and receive again, select boundary clock measurement. We've configured the master as before, and once you've done that, you configure the slave. We showed you how to do that under the configure slave button just a second ago. So most boundary clocks don't have slave recovered clock outputs to measure directly, and you have to infer the boundary clock performance from what comes out of the boundary clock master. Now the TIM-TAM measurement measures the accuracy of the transfer of time across the boundary clock, and TIM-TAM displays the variation of time over time of T2 minus T1, and this is a simple and direct measurement of boundary clock performance. So now we've seen how intuitive and easy it is to set up and make measurements with the Paragon-X's master-slave capability. Let's go back to the slides here. So versus real master-slave equipment, the key benefits are instrumentation, in other words, 2 masters allowing best master clock algorithm testing and all the necessary settings and fields brought out to a single simple user interface to allow detailed testing beyond what is viable with network equipment. This includes flexible setup and negative testing because there are no restrictions in how the field values can be set and combined. And remember, we've been told by network equipment manufacturers how easy it is to operate and change the settings here versus a real network equipment. The Paragon-X brings new timestamp transfer accuracy measurement, TIM-TAM, which is the only valid method for precise time transfer measurements across boundary clocks. And versus traffic generators, our precise latency measurement accuracy is there for master-slave capability integrated with high accuracy timestamp latency measurements, allowing high precision transparent clock testing to standards. Paragon-X also brings test independence as the entire stimulus response chain is in the test equipment, providing an impartial and independent view of the device under test performance. So the Paragon-X has everything in one box, master-slave integrated with sync key, packet impairments and packet metric recovered clock measurements, plus sync key physical layer jitter measurements, all under the control of one simple GUI or API. Thanks very much for your time, and that brings to the end of today's presentation and demo. Thank you.